asymmetric client and server programming experience. One of the most appealing aspects of ASP.NET Web APIs being built around this HTTP-focused object library is that the library can be used not only on the server but also in client applications that are built using the .NET framework. This means that the HTTP requests shown here can be created with the same HTTP programming model classes that are ultimately used to work with the request inside of a web API, as shown later in this chapter. As you'll see in Chapter 10, there's a lot more to the HTTP programming model than simply manipulating the various data elements of requests and responses. Features like message handlers and content negotiation are built directly into the HTTP program model so that you can take advantage of them on both the client and the server to deliver sophisticated client-server interactions while simultaneously reusing as much of your code as possible. Flexible support for different formats content negotiation will be talked about in much more depth in Chapter 13. But at a high level, it is the process whereby a client and server work together to determine the right format to use when exchanging representations over HTTP. There are several different approaches and techniques for performing content negotiation, and by default, ASP.NET Web API supports the server-driven approach using the HTTP accept header to let clients choose between XML and JSON. If no accept header is specified, ASP.NET Web API will return JSON by default though, like most aspects of the framework, this default behavior can be changed. For example, consider the following request to an ASP.NET Web API service. Get HTTP //localhost 50650 /API greeting HTTP /1.1 because this request contains no accept header to provide the server with a desired format. The server will return JSON. We can change this behavior by adding an accept header to our request and specifying the correct media type identifier for XML1. Get HTTP //localhost 50650 /API greeting HTTP /1.1 accept application /XML. No more coding with angle brackets. As the .NET framework has matured, one of the ever-growing complaints from developers has been related to the amount of XML configuration required to enable seemingly basic or even default scenarios. Even worse, because configuration controlled things such as which types should be loaded at runtime, configuration changes could introduce errors into a system that would not be caught by the compiler, but only at runtime. One of the biggest examples of this complaint can be found in ASP.NET Web API's predecessor, WCF. And while WCF itself has improved in the amount of configuration it requires, the ASP.NET Web API team went a totally different direction by introducing an entirely code-based configuration mode. ASP.NET Web API configuration will be discussed at length in Chapter 11. Unit testability as techniques such as test-driven development (TDD) and behavior-driven development (BDD) have become more popular. There has been a proportional increase in frustration with many of the popular service and web frameworks over their use of static context objects, sealed types, and deep inheritance trees. These techniques make unit testing challenging enough objects become difficult to create and initialize in isolation from the underlying runtime. They also are very hard to substitute with a fake instance for better testing isolation. For example, ASP.NET relies heavily on the HTTP context object, while WCF similarly relies on operation context or web operation context depending on the type of service. The fundamental problem with static context objects like these is that they are set up by and rely on their respective frameworks' runtimes. As a result, testing a service that was developed using these context objects requires actually starting a service host and running the service. And while this technique is generally acceptable for integration-style tests, it is unsuitable for a development style such as TDD, which relies on being able to run smaller unit tests very quickly. One of the goals in ASP.NET Web API is to provide much improved support for these kinds of development styles. And there are two characteristics of the framework that accomplish this goal. First, ASP.NET Web API has the same programming model as the MVC framework. This enables it to take advantage of the testability work that was done a few years ago, including abstractions to avoid having to use static context objects and wrappers so that fake instances can be supplied to unit tests. Second, remember that ASP.NET Web API is built around the HTTP programming model. The objects in this model are effectively simple data structures that can be CRE, edited, configured, passed to an action method as a parameter, and analyzed when returned. This enables unit tests to be authored in a very clean, focused manner. As ASP.NET Web API has evolved, testing has remained a focus area for the team, as evidenced by the HTTP request context class in Web API 2. Testability will be discussed at greater length in Chapter 17. Multiple hosting options. Despite some of its lesser qualities, one of the greatest attributes of WCF was its ability to self-host, that is, its ability to run in any process. For example, a Windows service, a console application, or Internet Information Services (IIS). In fact, this kind of hosting flexibility made its limitations in unit testing almost bearable, When consolidating WCF Web API with ASP.NET to form ASP.NET Web API, the team wanted to keep this self-hosting ability, and so ASP.NET Web API services, like WCF services, can run in whatever process you choose. Well, look at hosting in much greater depth in Chapter 11. Getting started with ASP.NET Web API. Now that we've reviewed some of the goals behind the development of ASP.NET Web API, let's dive in and take a look at some of the various elements that you will be working with as you create your own web APIs. One of the simplest ways to accomplish this is by creating a brand new ASP.NET Web API project and looking at the artifacts that the project template creates. To create a new ASP.NET Web API project, navigate to the web node in the New Project dialog and select ASP.NET Web Application Figure 3:1. Figure 3:1. MVC4 Web Application Project in the Visual Studio 2012 New Project dialog. Once you choose to create an ASP.NET Web application, you will be presented with an additional dialog that gives you the ability to choose various project configurations. From this dialog, you will see the option to create a Web API project. Figure 3:2. Figure 3:2. W. If API project type in the MVC4 New Project dialog. The key thing to note through this process is that Web API is simply a different project template within the family of ASP.NET projects. This means that Web API projects share all of the same core components as the other web project types, and differ only by the files that the template creates for you as a starting point. T also means that it's both valid and desired to include web APIs in any of the other templates shown in Figure 3-2. In fact, at the end of the day, ASP.NET Web API is simply a set of classes built on top of the Web API framework components and hosted by a process. Whether it's the ASP.NET runtime as the default template sets up or your own custom host as we will describe in more detail later in this chapter. T. His means that a web API can go into any type of project, whether it's an MVC project, a console application, or a class library that you reference from multiple host projects. The ASP.NET Framework components are made available to your Web API projects via the NuGet Package Management application. T. The NuGet packages listed in Table 3-1 are installed by the default project template. To create a Web API in your own project, you simply need to ensure that you've installed the same packages based on the level of functionality that you require. Table 3-1. NuGet packages for ASP.NET Web API package name, package ID, description, package dependencies, Microsoft.NET Framework for HTTP client libraries. Microsoft.NET.HTTP provides the core HTTP programming model, including HTTP request message and HTTP response message. Now, Microsoft ASP.NET Web API. Microsoft.ASP.NET.Web API NuGet Meta Package providing a single reference for installing everything needed to create and host a Web API in ASP.NET. Microsoft.ASP.NET.Web API.WebHost. Microsoft ASP.NET Web API Client Libraries. Microsoft.ASP.NET.Web API.Client contains extensions to the core.NET framework for HTTP client libraries to enable features such as XML and JSON formatting as well as the ability to perform content negotiation. Microsoft.NET.HTTP NewToolsoft.JSON. Microsoft ASP.NET Web API Core Libraries. Microsoft.ASP.NET.Web API.Core contains the core Web API programming model and runtime components including the key API controller class. Microsoft.ASP.NET.Web API.Client. Microsoft ASP.NET Web API Web Host. Microsoft.ASP.NET.Web API.WebHost contains all of the runtime components needed to host a web API in the ASP.NET runtime. Microsoft.Web.Infrastructure. Microsoft.ASP.NET.Web API.Core. You can use the package ID to learn more about the package by appending it to the URL ID. Being NuGet package dependency means that when you install a package, NuGet will first attempt to install all of the packages on which the package depends. A NuGet meta package is a package that contains no actual content of its own, but only dependencies to other NuGet packages. D1 used by ASP.NET Web API, NewToolsoft.JSON is an external component available for free download. In addition to the NuGet packages that are installed as a part of the default project templates, the NuGet packages shown in Table 3-2 are also available. Table 3-2. A. Additional NuGet packages available for ASP.NET Web API package name, package description, package dependencies. Microsoft ASP.NET Web API self-host. Microsoft.ASP.NET.Web API.self-host contains all of the runtime components needed to host a web API in a custom process, for example, console application. Microsoft.ASP.NET.Web API.Core. Microsoft ASP.NET Web API OIN. Microsoft.ASP.NET.WebAPI.OIN allows you to host ASP.NET Web API within an OIN server and provides access to additional OIN features. Microsoft.ASP.NET.WebAPI.Core, Microsoft.OIN, OIN. Looking at the set of NuGet packages as a graph may give you a better understanding of which package or packages to install in your project based on what you are trying to accomplish. For example, consider Figure 3-3. Figure 3-3. New. Get package hierarchy for Web API. As you can see from the dependency graph, installing any one of these NuGet packages will automatically install all of the NuGet packages that are connected, directly or indirectly, to it. For example, installing Microsoft.ASP.NET.WebAPI will install Microsoft.ASP.NET.WebAPI.WebHost, Microsoft.ASP.NET.WebAPI.Core, Microsoft.Web.in. Infrastructure, Microsoft.ASP.NET.WebAPI.Client, NewToolsoft.json, and Microsoft.NET.HTTP. Exploring